So welcome back. In this video we are going to study the topic ARP. ARP is nothing but address resolution protocol. So it is used to discover a PC's MAC address from its known layer 3 IP address. So ARP, in simple terms, ARP has a resolution to find a MAC address of a PC from its known IP address. So it consists of two messages. First is ARP request and ARP reply. So ARP request is nothing but it's like a broadcast message sent to all hosts on the network, and then ARP reply is like a unicast reply which is sent to only one single host. So let's take an example through which we can know the ARP better. So let's take like two switches connected with two more of the PCs, and let's consider an MAC IP address of 192.168.1.0/24 and .1, .2, .3, .4 respectively, their IP address in that subnet. So let's consider PC 1 MAC address as 9D00 and then 3900 of PC 2. So we are supposed to send a frame from PC 1 to PC 3. So the source IP is 192.168.1.1 and destination is 1.3. So the source MAC address is known. So we need to find the MAC address of the PC3. So this is basically address resolution protocol. So let's see step by step. So now the first step is like ARP request. So it will just send, as I said, ARP request is a broadcast message. So FFF means like it's like a broadcast MAC address. So it will just broadcast to everyone like who knows this address. So let us see. So at PC1 the ARP request is being sent over to switch 1, and now it will broadcast to every other interface except from which it has been received on. So now it will just say currently it will just update its IP address, the MAC address table, since it has dynamically learned the MAC address that PC1 is on the interface G00 and the MAC address is 9D00. So now this is basically called dynamically learned MAC address. So now, as I said, like switch 1 will spread to other broadcast to other ports. So now PC2, as it knows that it doesn't have that frame, so it will just drop it, and then now it goes to switch 2. Now it's still unsure that where the 1.3 IP address is. So now as soon as the frame reaches over the switch 2, it will just learn that this MAC address has arrived from G02 interface. Like it will basically know that PC1 has come from G02 interface. Now further it will just broadcast its IP address, the request, and then now it will go to PC4 and PC3 respectively, and then since PC4 knows like this IP address doesn't match my IP address, it will basically drop the frame. And now PC3, once it knows that this it knows that it has reached its destination. So now in this process has been completed, and now a known unicast frame will be sent. So now it will update the destination MAC address. Now it will be switched to source MAC address, and then the destination MAC address would be this. So coming next, so the reply, the source MAC address is of PC3 and the destination MAC address is of PC1. So the unicast reply will go on. So it knows it will send to switch 2, and then now once it sends to switch 2, it will dynamically learn where the PC2 comes from. So G00, and then you see over here, and then this is like a known unicast frame, as we seen known this term in the last video. Further it will send to switch 1. Switch 1 will come to know that PC3 comes from G02. It will update its MAC address table, and then it will as it knows like PC1 is on G00 interface, it will just forward it to G00 interface at PC1. So in this way the ARP request and ARP reply process takes place. So let's take an example to see how this process takes through the Wireshark. So basically a ping command is being used. We'll see how the configuration or like the process takes place. So the ping is like from PC1 we are pinging to a MAC address of 1.3. So from here we can see it's like sending an ICMP echo request that to 1.3. You can see dot exclamation exclamation exclamation. So dot is nothing but it represents the ARP process being taken place, like taking place, and then you can see the ARP table over here. So let's just study what is ping at first. And ping is used to like a network utility that is being used to test the reachability. So it generally measures the round trip time. So it has two messages, ICMP echo request and ICMP echo reply. So the command being used is like ping IP address. So as you see over here, ping and the IP address of that. So and then as I said, ICMP echo request and ICMP echo reply. So let's just consider a scenario in Wireshark. So basically I'm pinging from PC1. So this is the like 9D00 PC1's MAC address, and now it will just send a broadcast message like ARP request. So that's the broadcast, and then you see over here it's like who has this IP 1.3 tell 1.1, that is PC1, like where is PC3. So further, once the frame reaches the PC3 updates its MAC address, like the source MAC address, and then the destination will be the MAC address of the first PC, as you see over here. And then it says like PC3 is at this MAC address, it will just send over there. So once it knows the MAC address, it will just send ICMP request and reply. So as you can see, there are four request and reply, ICMP request and reply. So it just checks like whether the test the reachability 4 times by ICMP request and reply. So once it's going to PC 3, then coming to 1, then 3 to 1, 3 to 1. So basically this step is nothing but like first is ARP process, then ICMP request and reply, first, second, third and fourth. So this is nothing but the 4 request and reply messages. So this is all we have we need to know about ARP. So hope you understand this concept, and thank you.